Hello, my name is Chero-Osorio. I am a PhD student in environmental engineering at the University of South Florida, and I conducted a research at the University of Surrey in England, which consisted of confining bacteria for removing ammonium in synthetic biofilms for wastewater treatment. I was advised by two researchers, Dr. Ketty and Dr. Guo, and here's a picture with Dr. Guo's research group. The motivation behind this project is ammonium removal from wastewater. Conventionally, ammonium is oxidized and reduced by different microbes, and those microbes require certain conditions. For example, oxygen, energy, organic carbon, and other chemicals. It seems to be effective for wastewater treatment plant, but the drawbacks are the high energy input, the energy costs, and organic carbon and chemical inputs. But also, the energy means more carbon footprint. Another sustainable strategy consists of partially oxidized ammonium to nitrate and then introduce a process that can convert ammonium to nitrogen gas in anaerobic condition. So there is less energy required for aeration and less chemical input. And then this new technology seems to provide a more sustainable, efficient, and with lower carbon and environmental footprint than conventional process. This process combines nitritation and anaerobic ammonium oxidation and is called partial nitritation anamox or deammonification. Although being very sustainable, the microbes involved in this process are challenging because of the sensitive nature and the slow growing, especially the anamox bacteria. One way to further promote it to be more successful for wastewater treatment plants will consist on providing synthetic biofilm to allow them to be more resistant against competitor microbes or external factors. At the University of Surrey, they developed a way to create synthetic biofilm for bacteria based on the biocoating formation with polymer. Bacteria is suspended in the latex dispersion, and particles are packed around the bacteria, followed by coalescence upon drying, and forming a synthetic biofilm. Here's a picture describing this biocoating formation process developed at the University of Surrey. And sometimes haloxide nanotubes are also introduced to increase the porosity and permeability of the biocoatings. The methodology I followed was using the bacteria involved in PNA, which were enriched and shipped from the United States. And I also combined this bacteria with latex dispersion and haloxides. For partial nitritation in animals, the reaction will consume ammonium, and the final product will be nitrogen gas when combining both. So my results will be able to describe ammonium consumption. I also wanted to compare biocoating versus natural suspended biomass for both microbes. And what I can conclude was that for AOM, the ammonium consumption was at a similar rate in the biocoating as in the microbial suspension only. For animals, there is some difference for the biocoating, which was at a slower rate than animal suspension. I would also like to emphasize that animals is slow growing, so this means that it's a good start because of the slow growing nature. This was a recap of my research at England, and thank you for your attention.